Hi students. This video is the continuation on the stack operation again. So I'm going to draw a table here. Okay, so wherein I have already filled the first column where AM stands for the addressing mode. We have already seen in the previous video what is FA, FD, EA and ED. Once again I'll just go about this in a jiffy. FA stands for full ascending, FD stands for full descending, EA stands for empty ascending, ED stands for empty descending. Now I've just written two more columns here which I'm going to fill. What are the equivalent pop, that is what are the instructions for pop operation and push operation? What is the equivalent ARM instruction? So we are going to write that, as we had already said in the previous video, what pop mean. Popping is actually taking out or moving the data from the memory location to the register in the ARM core. So which is that instruction? It is LDM, right? So it is LDM and then append this particular addressing mode. Similarly, you do this for all the pop operations. So this will be again LDM, FD, LDM, EA and LDM, ED. Similarly, you can fill the push operation also, the equivalent ARM instruction. So we already know that it is STM. Similarly, append this STMFA, STMFD. We'll do that fast. STMEA and STMED. Once you've completed this, okay, why am I doing this is just for you to understand that when we write this particular instruction, okay, it clearly means that pop. Okay, it has to do the pop instruction. Okay, since we have given us full and A, ascending. In the previous video, I had not mentioned about what is ascending and descending. Ascending means the stack will grow upwards, which means it is going to increment towards higher memory addresses, whereas the descending, in contrast, descending means the stack is going to move downwards, that is, it is going to decrement towards lower addresses. Okay, I hope the ascending and descending concepts are clear to the students. Okay, now when this instruction, ARM instruction, is written, what will be the equivalent LDM instruction? We are going to see that. That is with relation to whatever instruction we had studied earlier on. That is, we had LDM-IA, LDM-IB, right? And LDM-DA and LDM-DB. So with reference to that, we are going to see the relation to that. Okay. So we'll just write here the equivalent code for that. So right here LDM, since it is full and ascending, so full ascending, full means, I told you, full stack, the stack pointer will be pointing to the last used location or to a full stack, right? So last used means, so what should I, so since it is ascending, it must be I, incrementing, which is being done, ascending, right? So +1, +2, etc. increment. And since F stands for a last used, so what do we need to do? Last used means we cannot store a data in that. So what we need to do? We need to increment priorly. That's why we are using it. So what you have to do is, okay, since this instruction, I made a mistake here. This is LDM here, right? So we are storing to the stack. So we are going to use STM. So we are storing to the stack first. So okay. So similarly, I'm going to write here IB here. Okay. So there's a small mistake which I've done here. It's not supposed to be there. We are going to fill this first for the ease of understanding. We are going to use push instruction first. Okay, that is pushing onto the stack. Okay, and then we will use the popping. Okay, so because once we write this, we can always do the reverse engineering back. Okay, so I hope the same concept here. F and A, ascending means increment, full stack means its stack pointer is pointing to the last unused last used location. Since the data is already there, you need to increment the location beforehand itself. That's why B here. Now let's go to the next push instruction, ARM instruction. So here it will be again STM, again full. Descending means we are going to the lower addresses, right? So we need to decrement, right? Yeah, and then since it is full last used, we need to do this instruction DB. Similarly here also STM. Now be careful here, ascending means again increment. Since it is empty stack, okay, empty stacks means nothing is SP 0, or what we can say is the SP will be pointing to the first unused, right? It is unused, so we can fill the data, so we can do the incrementing of memory location later also. That's why we are giving A here, after. Similarly here STM, since it is descending, okay, here, so decrement, descending decrement, and here it's an empty stack. So what we are going to do is, we can do the decrement after, right? So once we get this, okay, what we can do is we can write the equivalent LDM. Okay, so I made a mistake here. So LDM IB, referring to the previous video where we had written the LDM as well as STM pairs, right? Now you can relate that and use that video for clearing this problem here. So STM IB, the equivalent will be DA, right? Similarly here LDM, it will be IA. Similarly here LDM DB, and here it will be LDM IB. I hope you got this concept. Thank you.